it up. Then last but not least, we go to mixture. This is when two or more substances are added together without any chemical bonds being formed. They don't need chemical reaction electrolysis. I can just separate them easily by physical means. Physical means physical separation techniques. For example, like filtration. Yeah, for the fun of it, okay? Filtration. Like distillation, magnetic separation, right? All right. We're going to go into this in the next topic. What is mixture? All right, keep it simple, right? Mixture to me, in Singapore, right? I don't know, we call this the Indian or the Malay or the Chinese rojak. You know rojak? You mix anything together. So it can be made out of elements and or compound. You can mix them together. I don't care. It's just a mixture. The components of a mixture, once again, are not fixed. They can be present in any ratio, right? Can be any ratio. You like this, you put more. You don't like this, don't put at all. Okay. There are three types of mixture. First is when there are two elements, all right? So let me use the color very quickly. All right, two elements. So neon look like this. All right, so Ne look like this, Ne look like this. Hydrogen is diatomic. So this is a mixture of two elements. Although one is monoatomic, one is diatomic, but both are still known as element. Don't forget. I want you to get used to all the terms so that we don't allow ourselves to make any mistake when we proceed to the next topic and topics. Okay, next, mixture of two compounds. All right, water, once again, looks a bit weird like this. It's called the inverted Mickey Mouse here, all right? Carbon dioxide, all right, all right. A very cartoonized way of showing it. It looks something like this, okay? So, okay, carbon dioxide. So it's a mixture of two compounds. Can be element or compound. And obviously, it can also be what? It can be element and compound. Nothing wrong. Whatever color I use, okay? Element and compound. The shape why it look like that, all right? We'll be talking about it very soon, okay? NH3. Sorry, this is a bit ugly, huh? NH3. This H and this H. NH3. All right, so once again, it can mix around any one of these kinds. No problem. Okay, where are we now? We are in this special mixture. It has a name. It's called alloy. All right, again, not new. Sec 3 or Sec 1, Sec 2 learned before. What is an alloy? Is a very important example of a mixture. Okay, so an alloy, the formal definition, those by Sec 4, we just finished this, right? There is always what? There's always the requirement of a main metal, all right, and other elements. The elements usually are metals, but sometimes could be non-metals such as carbon. And these are the four important ones that I need to memorize. It will come out just to ask you what are the elements inside. The percentage, you don't have to remember them at all. I put it there to show you who is the main element. Everyone okay? So once again, don't memorize the number. That's why I never bold them. Here we go. I believe these are the four you need to know. The last one is extra. Steel and stainless steel. They have the main metal. I need to appreciate this iron. Steel has carbon. Stainless steel, obviously still have carbon. You have two more elements you add in. It's called chromium and nickel. Okay? To make it stainless. Stainless steel is where you use it for cutlery, you know, the chicken chop knife, the spoon. Red rust, the one I buy from IKEA, 90 cents. Used for 20 years already, still haven't rust a single bit. But eventually it will rust. Okay? That's like, it's not forever. Okay? But it's just resistant. All right? Next. Okay, these two I hate. Okay, it's called brass and bronze. Okay, how I do? Brass and bronze, first of all, has the main metal called copper. The important thing is how do I remember is zinc and tin on the other side. Okay, this is what I do. I share with you, okay? I write out the symbol for zinc. If you want to follow me in terms of how I memorize it, okay? Because this one don't memorize, you'll never get it like they ask, all right? This tin. Tin is Sn. Okay, tin is Sn in the periodic table. So what I do, I tell myself this is like it's a diagonal relationship. I show you where's the diagonal. That's how I memorize it. You need to have strategy. S is here, right? S is here. Okay. My way of memorizing. You don't like, then don't use. Zach is here. The second alphabet of the English word of the alloy, right? Show me what is the element that I add. That's what I do for memorizing. I need strategy. You have your own. Okay. Duralumin. The main metal is called what? The main metal is aluminium. Want to make a guess where we use duralumin? Aluminium is very, very light. You ever use aluminium foil at home before? Aluminium foil is very light. When you go holiday, usually a lot of times you have to take this. The airplane that you sit, that it flies, the material is called duralumin, whether it's Airbus or Boeing. These are the two main brands in the market. Yes? This is the duralumin. It's an alloy. One, and a particular question will come out. Why don't you use just pure aluminium? Why? It's so light, what? You add copper, magnesium, you make it even heavier. May I know why don't use aluminium to make airplane? Since it has very low density. Yeah, come. Yeah, whoever. You like go holiday, you don't know what the plane you sit, what it's made of. Yeah, it's very malleable and ductile. You see only before it fly, like plasticine like that. Like Play-Doh. Understand, everyone? Right? So it make it an alloy, it becomes less malleable. It becomes stronger. Okay, it makes it stronger. Okay, so basically we use an alloy. All right, my Sec 4 student, I thought we just discussed this. Okay. I don't think we have to memorize the elements, but yeah, if you want, you can memorize this copper and magnesium. The first four is important to me. Okay, the last one, duralumin, I just need to know that it's used for airplane. That's it. Okay, last one, and we finish the topic. Okay, content. Go fast. Go back. Okay, this is where the marks are. How will you come up? Never don't know. If you come up, they will say, hey, using examples, for example, discuss the difference between a compound and a mix. Sure. Okay, there are differences. The strategy I use here is called SPECMB. Just basically the first word. SPEC stands for separation, properties, energy changes, I think it's composition. MB stands for melting point, boiling point, as stated there in bold. Yeah, very simple. Okay, let's run through this and done with it. Okay, separation. Let me use two different colors. Compound, mixture. We talked about this before. A compound is pure, but it can be separated by chemical means or by electrolysis. I can break it into this element or smaller compounds. I can break it up using harsh method like this. Mixture can separate. Can. Don't need chemical reaction. You just use physical separation means like distillation, evaporation, filtration, blah, blah, blah. Done. 1 mark. Separation. What about the properties? Oh, this one is shook. Okay, I'm going to cross topic right. Ladies and gentlemen, a compound, the physical and chemical properties of the compound will be different from their elements. Okay? Let's talk about chemical properties first. Okay, give you the example. Number one, chemical property. Oxygen is required for burning. Everyone know? Combustion, yeah? Supports combustion. You need oxygen to burn something, to combust something. Yes? So this is the element. What can I say about a compound that's made of oxygen? Say water. Water is a compound made from oxygen. Okay? O2H2 give you H2O. Does not support combustion. So once again, they are different in terms of chemical property. Important, okay? I use a bit of different colors, so at least you can match them, see a bit, all right? Physical property, what can I say? I think easy. We use what we learned in kinetic theory. O2 and H2O, I hope you agree with me, they have different melting point and boiling point. Physical property. Chemical properties of a mixture, we're talking about mixture right now, are the same as its components. With a name example, explain this. Give you 2 marks. I use the same example. Okay? O2 supports combustion. O2 means pure O2. Currently, our air right now, is it pure O2? Obviously, it's not. What is it? There's only 21% oxygen. Yes? But does air supports combustion? Yes, the people smoking downstairs right now. I can smell it. Yes. Air supports combustion. Chemical property is the same. Because it's like rojak. You know with me? You know rojak? Right. I like more pineapple, I put pineapple, okay? It's a moja. But when I eat the rojak, I can still taste the pineapple. Can still taste the bean curd. It's a bean curd or something like that. Right? Right. I can still taste this, taste that, right? It's still part of the taste of the individual items. A mixture, obviously, the melting boiling point is different. In kinetic particle theory, we say before, right? What happens when we add impurity? The melting point and boiling point will not be fixed. It boil over a range. Am I okay? Make sense? All right, a mixture is impure. So impure means what? Means you have variable melting boiling point, and you will lower or increase it. We'll talk about this in the next topic. Next, energy changes. When a compound is formed, a chemical reaction always occur. Okay, and there will be energy changes. So there are energy transfer. So what we will have is usually you have light is given off, high chance, or heat is given off or taken in. So there are energy like heat and light that are being transferred when a compound is formed. In a mixture, no chemical reaction take place, and therefore there's no such things as light or heat given off. Right? It's just you mix them together. Okay, that's it. Keep it. All right, done. Keep it simple. Okay, last two, and we're almost done. Here we go. Composition. Okay, for a compound, all right, the composition by mass is fixed. So for example, in water, every water molecule is made of 2 hydrogen atoms and 1 oxygen atom. It is fixed. You cannot change it. All right, a water molecule is always like that. A carbon dioxide molecule is always like that. But a mixture, as I mentioned, rojak is different, right? I use different color, right? Any whatever color, okay? Is variable, right? Do you know that the air in Singapore is different from the air in, say, Indonesia during the May-June period? Yes? Remember the haze? It only stopped during the pandemic. Yes? After the pandemic is over, the haze is back. Yes. Yeah? All the air is different. Melting point, boiling point. We learned this already. Consider done. White color. A compound has fixed melting boiling point like water. All right? 0 degrees Celsius, 100 degrees Celsius. Whereas a mixture is variable oxidation, what oxidation? Variable melting point and boiling point. If you would like to catch my latest videos, click on subscribe button right now. And click on the bell if you want to receive instant notifications once I've uploaded my latest video. If you would like to join my live chemistry classes and revision workshops, go on to winnerseducation.com and find out how you can score distinction for chemistry on a consistent basis, either in our center or online via Zoom. If you want to check out my online school, go on to passwithdistinction.teachable.com. You'll be able to learn chemistry concepts at your own pace and anywhere in the world, topic by topic. This is Sean Chua from Winners Education, to your distinction in chemistry.